I think it's almost time to start. It's sort of like making popcorn. Once the number of noises you hear from people coming in starts getting less, you can sort of assume that you can start. So I'll start the meeting. So welcome everyone to the final presentation of the testbed on spatial data APIs. I'll first give a quick introduction of why we organized this testbed and what our aims were with the testbed. And then we'll get into the meat of things with 5 presentations by the 5 companies that did each of the research topics for us. So my name is Frank Terpstra. I'm with geonovum. And I was the person coordinating this testbed. So what was the motivation of geonovum to organize this testbed? APIs offer the promise of much broader use and reuse of geospatial data. And as geonovum, we want to encourage the use of geospatial data within the public sector in the Netherlands. So we wanted to know, do current API standards live up to this promise? And what hurdles currently exist for using APIs to encourage the reuse of spatial data? And if these hurdles exist, can we eliminate them? So we want to provide feedback to standards organizations such as OTC. I'm very happy to see many OTC members as well as people from OTC themselves. So welcome to Scott and Gobe. And we want to provide feedback to our own national initiative on APIs. We have a knowledge platform APIs, where we make national standards on how to deal with APIs. And specifically, we're currently working on a geo extension to our standards on APIs. So we want to provide feedback to that as well. And if you're not Dutch speaking and you're thinking, what's up with the monkeys? API is Dutch for monkey, so that's why I have some illustrations using monkeys. So in more detail, geonovum is a standards organization, and we're responsible for national standards for sharing geographical information. And currently we have OTC standards, WMS and WFS as mandatory standards on national lists of mandatory standards for the public sector. One of the things we want to know is what's the right timing for starting to add OTC API standards to this list, or maybe other API standards. When should we do that? For the current OTC standards, WMS and WFS, we have national profiles. Do we need profiles for API standards? So these are the sort of things we are trying to get answered. And also, as I was telling you, we are working on an extension for the national standard on REST API design rules, which is a set of guidelines if you work in Dutch public sector and you want to offer an API, what rules should they adhere to? And we want to make an extension. What should you do when you're offering geospatial data as an API? Now, this testbed it's actually on, excuse me, it has actually been underway for quite some time. I think we're almost a year into it. And the first phase was realizing testbed infrastructure. So we put up an infrastructure where you could easily launch OGC APIs. And you can find this infrastructure if you follow these links. We can provide these to the presentation to you later, so you can look at them yourself. So that was the first part we did, and we finished that just before summer 2021. And then the second part, and that's where you have joined the final presentation for, was we did a tender. So we did a tender, we invited parties to participate on 5 research topics. And we had a rule of 1 party per research topic, and also we were explicitly looking for at least some of the research topics for parties without extensive spatial data experience. So people that are new to the field that can actually give us insight if these API standards make it easier to get into the geospatial data if you don't have much expertise. We try to do it as transparently as possible, so anyone could follow the progress. We have a public GitHub, and our previous intermediate sessions were also public. We have an aim of reusability and a preference for open source. So many of the products you will see in the presentations that are coming up are actually available open source. And also the final reports on each of the research topics is publicly available to anyone. So, what are the research topics? The first research topic is CRS extension for spatial APIs. So there is an extension for OGC APIs to deal with multiple CRSs for coordinate reference systems. And we wanted to know how easy is it to implement, and also how does it compare to a method we had already employed in the Netherlands, which was a different way of dealing with different CRSs. Then the second research topic deals with spatial data API discovery. Around 5 years ago, we also organized a testbed, and one of the main things we tested there is how well is spatial data discoverable on the web. So how easy is it to index in Google? And we basically wanted to know, using these new API standards, have things improved, because the theory goes that this should offer a big improvement in the discoverability of APIs. So IC Technologies took up this research topic. The third topic is client implementations. How easy is it actually to make an API client? The promise is that this should be very easy, but we wanted to check. So Ahmad Ayubi from Canada, who is currently a computer science student, took up this topic and tried to implement several different clients and also compare it to a baseline of existing standards. Then we also want to look into the difference between a generic approach offered by OGC APIs versus a convenience API approach, so an API tailored towards a specific geospatial function. And Purple Polar Bear, Dutch company, researched that. And then finally, we wanted to look into the combination of simple and linked data encodings in combination with the use of spatial data APIs. And Swirl took up that research topic. So what we're going to do now is we're going to go through each of the research topics. People who did the research will present. For each topic, we will take about 20 to 25 minutes to present, and 5 to 10 minutes are available for questions. If you have any additional questions, please put them in the chat. And we might also be able to organize separate meetings if you want to go into more detail. So with all this introduction out of the way, I think it's time to move on to the first topic. So I would like to hand my screen over to Bart.
Yes. Start the presentation will be nice. There we go. Thank you. As Frank already mentioned, we have been looking at the COS extension for spatial APIs. But first, let me show you how who we are. Then I'll get into the details of what we researched and our findings, and how you can proceed with these findings for your own benefit. As Frank mentioned, well, we are geospatialisten. As Frank also mentioned, the focus was on companies who don't have a lot of geospatial knowledge, but being geospatialist, that seems a bit counterproductive. However, we started about a year ago with some web development, and we have a team of developers that are mainly web developers without any GIS background. So they had quite an outside look on the OGC API standards, despite we're working at the GIS company. And of course, for the GIS part, well, my background is in GIS and I could help them with that part. But the development is done and the implementation of the API standards is done by a team of well, web developers indeed that know a lot about web development, the part I don't know much about. So in that regard, we could still fit that request from GeoNova to come with an outside view on the specifications. I won't go much into the details of the company further. But for this research, we defined 5 goals. First of all, is to demonstrate how can we actually serve data in different CRSs. In our case, that was RDNU, the Dutch National Projection, ETRS 89, which is the European CRS. And indeed, we had a look at how can we implement that following the OGC API features part 2 CRS specifications. There's a bit of background here. The OGC API features specification part 1 is the core, and that's simply serving geospatial data on the web through an API, but without the option of requesting different projections for your data. So you can only request your data in WGS 84. But as we all, well, at least as all the geospatial people in this session will know, there are many projections available. And the part 2 of the specification is an addendum to part 1 that allows you to request the data in different CRSs. Our second goal was to demonstrate how much effort it would take to serve that data set we use in this use case into those different projections. And to compare that with how the GeoNova has implemented it so far and how much different or how much more complicated or less complicated it would be if you would follow the OGC API specifications. Third goal was indeed to demonstrate how much more work it would be to convert an API that uses the well, GeoNova standard, so to say. That's through content negotiation. How much effort it would take to convert that to an API that adheres to the OGC API specifications. We also wanted to show by at least using one client how you can request data in a different CRS. So we'll have a short demonstration later in this presentation. And yeah, indeed how you can convert an existing API into an API that supports the OGC standards. First, we started by building the core mostly. In the README that we published on the Git repository, you can see which parts we included from the core specification, which parts we didn't. We chose not to implement the whole core specification, mainly due to time restraints. Then we only implemented the part that we needed to make the part 2 of the ODC API specifications work. And that is to be able to make a demo viewer where you can see data in different projections. Then to create an API that serves that data to that viewer that is capable of serving data in WGS84, ETRS89, and in RDNU. Because we didn't implement the complete core specifications, the API that we have currently that's available as open source in the repository is not completely compliant with the specifications, and the ODC has released an endpoint where you can test your API. That's unfortunately not successful at the moment with our implementation, simply because we didn't implement the full core specification yet. Another thing is that in that validator for your API, the validator expects you to use absolute links for all the endpoints in your API, whereas we implemented our API with relative links. In the beginning, when we started the development, we wanted to make an API that's easily deployable to any server or instance. There's something you can also use in a clustered way, for example. Clustered way is that you have multiple APIs next to each other, and in case that there's a lot of load on your API, so a lot of requests are being made, those instances of those API can work together. And that becomes a lot more difficult when you work with absolute links in your API. I mentioned earlier we have the GeoNovum way, so to say, and we have the ODC way. Both deal with content negotiation, and content negotiation is the process between the client and the server, where the client makes a request to the server to receive some kind of data. And it is asking the server in what kind of formats that's available. And then the client chooses a desired format that it wants to use. And then it gets the data in that format from the server. You see this a lot happening if you browse a website, for example. You see an image that can be a PNG or a JPEG. And which version you get depends on what your client can display and what the server has available. The same thing applies to the ODC API, to geospatial data on the web. The API has endpoints available where it's showing for each dataset which CRSs are available for a specific dataset. And the client can make a request to get a list of those available CRSs for a dataset, and based on that list, it picks the most desired value. For example, WGS84 if you use a generic web viewer that can show the whole globe, or if you want to have specific data from the Netherlands and you only want to use that part, you can make a request in RDNU, and then you get your spatial data in that CRS. You receive it back from the server. This whole process of content negotiation can be done in two ways. The way that GeoNovum initially implemented it, and if I remember correctly, but maybe Frank can correct me, by that time the ODC standard was not definitive yet. So the way that GeoNovum implemented it was to use headers in the request to make possible this communication between the client and the server to request a certain CRS. Currently, the ODC API standards, they want you to request the CRS through a URL parameter. So the requested CRS will be part of the URL that you send to the server. And based on that parameter within the URL, you'll get back your data in a certain projection. In our API, we initially included both these options, and from a developer perspective, it was quite well trivial indeed to implement both ways. Basically, you get the same information on the server. Only you get it in one option, you get it through the URL, and the other option you get it as an extra header parameter. But then the processing of the value of that parameter will still be the same. So for the most part of the API, it was quite irrelevant, basically, which of the two options were used. This is a screenshot to make it a bit more visible what I described. And here you can see that the geodata that's being received for this point on the map, it has a storage CRS property, which is part of the ODC API specification. And that storage property, here's my cursor, is in RDNew, CPSD code 28992. But the CRS that's being served by the server here, and it's being shown on the map because the whole map is in WGS84. Here we're also receiving the data as WGS84 or CRS84 in this case. And this will make it a bit visual to show you what that looks like in the browser. Let me zoom to a small area. And I can make a selection here. Select some data. I selected one record now. These are monuments within the Netherlands. And when I export, I can choose if I want 3857 is the ETRS89 code, PSD 28992 is the RDNew code, 4326 is WGS84. So in our demo, I can choose which CRS I want from the server and which file format I want from the server. I'll get into the details later. But if I say I want the RDNew data in the JSON-FG file format, I can download it. And in the background now, the website and demo viewer that we have online is communicating with the API. And then you see that the CRS of my data that I got from the API, from our backend, is in RDNew, which in this case is the same as the storage CRS. Well, the rest is just the content of the data with the feature that I selected now, with its properties in it, like the ID numbers, some links, in case you want to visit more details about the feature I selected and its geometry. This is really the client that we implemented, where you can visually explore the different projections that you get from the API. And there's also an API endpoint where, according to the OTC specs, we generated the description of how the API works. And here you can also make the manual request if you want. There's a try it out button where you can execute several commands according to the OTC API specifications, and then you get the response in your browser. I won't go over all the details, but you're welcome to test this API endpoint out. Frank already mentioned indeed the GitHub repository, and all the code and all the links are in here as well. So if you want to experiment with this after the presentation, feel free to do so. And of course, if you run into any questions, our contact details are also there in case you need help or you want to discuss things further. As I showed in our viewer, we have different file formats that you can download. We have GeoJSON and JSON-FG implemented in the current version of the API. There was also in the viewer the CSV file, but that's something that's generated separate from the API. So I'll ignore that for now. The GeoJSON, we implemented our viewer and most JS web viewers support this file format. And in the past, there was a standard of GeoJSON that was allowing you to store the different projections within the file that you download in the GeoJSON file. But currently, GeoJSON only supports WGS84, which is the global grid. Thanks to this testbed, if I say correctly, Marij from Geonovum pointed us on the GeoJSON FG file format. That's an extension that's being developed as a new geo standard on top of GeoJSON. It's still a work in progress, but one of the biggest benefits of JSON FG, the one I just downloaded and showed you, is that it can store data in different CRSs. And another personal benefit, if you ask me, is that it also stores the CRS of your geodata within the file itself. And I know that the OGC API standards APIs are mainly used on the web. But as a geospatial person, I also know that we often like to download data to manipulate it in a desktop client, for example, or to distribute it further, or to manipulate it or analyze it. And in that case, I think it's valuable that you store your CRS within the file itself, because if I take the JSON FG file, I can't see from the outside which CRS it is in. But now it's always coupled with the data. And if I send it to somebody else, you can also directly see, okay, I have this data that I got from Bart, and I see it's in already new projection. But there's no ambiguity. That for us is a very valuable addition to the file format, I think. Sorry. The demo that I showed you is also made with data. Okay, these are the Rijksmonumenten, so the national monuments that we have in the Netherlands, and those are both areas and points that are available. This is an inspired data set, and it's currently being used in a test to see if we can use the APIs we developed with the CRS extension to serve this data and while it still conforms to the Inspire standards. So this demo will stay online for at least half a year, possibly longer if needed. And that also gives Geonovum the option to experiment with the API that we have, so to see if they can serve the data with the new standards and are still being compliant with Inspire. I see I'm almost running out of time. So as I mentioned earlier, the results, they can be found in the GitHub. We included there's a folder with the API with instructions on how to set up the API. In much more detail, we described all our findings, and yeah, this is the part that we did not include. So if you want to have a fully compliant API, there's still some work to be done. In the future, we will try to continue to develop this API. But for the moment, that's on a best effort base. So you can subscribe to the Git repository and then you get notified of updates. But if there's really something missing, you can always reach out and we can see if we can still add it to the API. And well, lastly, it also contains some links to the demo if you want to use a visual interface to explore the API with. that was in short and just within the time. I see what we did the past 3 months for GeoNova. I hope I could make it a bit clear to you what we did, and all the best practices that I couldn't fit in the presentation, they're also in the README. I think we still have some time for questions.
Peter, you can also ask your question in person. So Peter Vertanos, you have a question, right? So when you say JSON-FG can store CRS in the file, the core only stores the URI of the CRS. Do you want that? Your microphone is not working. Do you want that, or do you want the actual definition of CRS in ProJSON or well-known text stored in the file?
Okay. First of all, sorry I didn't see your questions when I was presenting, because then I don't see the pop-ups. Now the JSON-FG stores indeed the URI to the CRS, and I think that's already enough. The URI that's included can include the identifier of the CRS itself, so the number 28992 for already new, etc. Then it can include the version. And I think as a geoscientist that receives that data set, it should already be clear enough to find what CRS is used within the data set. And I think that's the most important part of it, that somebody who receives a data set doesn't have to look up somewhere on the internet where the data came from, which might not always be known anymore, what CRS they have the data in, if they can find that. Okay, you're typing, so I hope it's clear enough. Okay, you're welcome.
So Bart, I also have a question for you. So you looked in into these two methods of doing CRS content negotiation. What would be your advice on combining them, or maybe moving from one method to the other? Yeah,
no, you're right. We discussed this before the presentation, but I skipped over it. Sorry. For now, I would recommend to go with the OGC API specification, which is including it in the URL. One of the benefits is that it makes it more indexable by search engines, for example, although that's not our research topic, but from others. And by doing so, I think it's making it more straightforward to also for a non-geospatial developer to find different endpoints. I know that there are already implementations that use the headers method. Well, as we saw during our implementation, it's quite trivial to include both. So I would recommend to first add the OGC way of doing it through the URI specification. That in that moment you can support both standards, and then in the future you can communicate to your users that you're going to phase out the non-OGC standards way, so through the headers communication. That gives them a time to upgrade their clients, and then they can well, then they have time to migrate their clients, and then they can all, in the end, everybody has time to use the OGC standards in the end.
Okay, there's a question from Olivier Ertz. Did you develop your own server implementation, or did you use an existing implementation?
Well, we developed our own API. The reprojection is currently done by the PostGIS database that's behind it. But the API itself is what we developed, and that's also the code that's available in the repository. Okay. There was a hand from someone.
Yeah, there was a hand from Gobe, but Gobe's hand is gone. So Gobe.
Yeah, I was just about to type the question in, but I might as well ask it. During the presentation, there was a mention of relative links with regard to CRS. Was that with regard to CRS, or was that with regard to the API itself? It wasn't clear whether this suggestion was to have relative links to CRS definitions, or whether or not it was relative links to the APIs. So perhaps you could clarify that, please.
Yes, the relevant links, that was concerning the whole API. The ODC validator that you can use to see if your developed API, if that is in conformance with their standards, it expects an absolute link to all the paths, which means that I would have to write every time, well, geospatial.nl / my dataset / my projection / my file format, so to say. And I have to use that within the entire API. And that works well for one domain like geospatial.nl, but if you deploy the API on a cluster of servers where you have multiple copies of the API next to each other, all with their different IP addresses or all with the different domains, then it's becoming much more complicated to maintain the integrity of all those links.
Okay.
So that's why we chose for the relative links.
Okay, understood. And so the same feedback, we had received the same feedback from another implementer, and we had implemented something into the executable test suite to support that. So it's possible that perhaps we might not have dealt with all the possible use cases. So I'll take your feedback to the engineers and see if we can address that use case.
Yeah, so indeed on the ODC validator, I think it was the Git page, there's still a ticket open for it where this is under discussion, but I'm not sure if that has been resolved now or not.
Okay, I'll look into it. Thanks for the feedback.
Yeah, and if you need more input from our developers, also let me know. I can bring you into contact with them.
Yeah, that's great. Thank you.
Okay, no problem.
There was also a question by Ed Lewis in the chat. So might the CRS work be merged with other services like PyGeo API or LD Proxy, which are already certified ODC compliant? And well, we as DNOVM are considering putting that into the market as well, making such a modification to PyGeo API, but we haven't decided and made the final decision on this yet. So the code of BART is not based on PyGeo API at the moment. Are there other questions? If not, then I would really like to thank Bart for his work. And if you want to have more detailed information, we can always schedule a meeting afterwards. So thank you very much, Bart, for all the work you did. And I'd now like to move on to topic 2. So thank you, Bart. Jonathan, can you take over?
Yeah, hi, Frank. Let me just sort my screen out. Right, can you see that okay? Yes. Good, you hear me all right? Good. All right. Morning, everybody. Welcome to the presentation. I'm going to present on topic 2. I'll budget on about half an hour or so with some questions and answers, because there's a number of people who haven't been at the other public presentations. I'll do a brief introduction as to the problem statement that we had as well. For those of you who don't know me already, my name's Jonathan Pritchard. I currently work for a company called IEC Technologies over here in the UK. I've been involved in hydrography and marine geospatial data for 20 odd years now. we're one of those companies that kind of straddles OGC with another standards development organisation, the International Hydrographic Organisation. So we're one of those topics where we sort of come a bit from the outside, really, and we are making comment on how OGC API standards relates to discoverability and the FAIR principles. Get off the company blurb. So yes, so as I say, we come from the marine geospatial community, represented really by the IHO, the International Hydrographic Organisation, and this was our problem statement for topic 2, as Frank mentioned in the introduction. We were looking at implementations of OGC API records and the methodology for it within our domain. With one of my other hats on, I'm also one of the co-chairs of the OGC's Marine Domain Working Group, and I also sit on a whole bunch of standards committees under the IHO for marine geospatial data, and they're kind of separate communities in a way. A lot of the standards don't really mix terribly well. And part of the Marine Domain Working Group's mission is to try and bring the two standards communities together. So this was a great project for us, really. It was a real test case to take data from our domain, which is generally used for the purposes of marine charting under the SOLAS Convention by international shipping globally, but also data that is now also being used, of course, for a whole bunch of broader use purposes for marine spatial data infrastructure, MSDI. Obviously, within Inspire, national institutions, and also, of course, under the UN GGIM's IGIF framework, marine data is becoming much more. There's a far greater requirement for interoperability for marine data coming from the IHO community than there ever was before. And the OGC Web Services gives us a really good opportunity to do that. So we were really looking at how could we take some data from our domain within the IHO and wrap OGC API records around its metadata and look at the different ways that the metadata is created and distributed, and what could be done. So our plan was to set up a testbed for a region using multiple IHO S100 data sets, which is really the sort of the flagship standard for all different kinds of data within the IHO, service metadata and discoverability, and see if we could expose that through OGC API records. The OGC API devoted to metadata. The object of the exercise is really then to feed back to the OGC community through the Marine Domain Working Group, through other bodies within OGC, and also to the IHO on how we can bring practices and content over metadata much closer together. So what I'll cover today, and it has been kind of a heavy week already, post-Christmas, trying to get all this sorted out, are a brief summary of how we've achieved these project goals, what we've done, the impact of them, and some observations on our two different communities that we're looking at, and how we can take all that work forward. So this is a slide that's been, we've done a few public presentations. For those of you who haven't been at all of them, we've done a few, and really this was the sort of the key insight for us was that certainly there's a slight difference of approach in terms of how OGC and IHO approach metadata. Within the IHO, metadata is very much apart from the data itself. There's a separate model that covers it, which is based on ISO 19115 and is encoded as its own encoding based on the ISO XML standards. Within the IHO, we construct these are model-driven suite of standards, and S100 defines a framework under which models are created for various types of marine phenomena. We create these things called feature catalogs, data, and then metadata from it. OGC API records is based on OGC API itself. So actually, it's an extension of the data content itself. So what we were doing within this project was really starting to make a much broader definition of how IHO metadata is constructed, and to use that as an input into an OGC API records implementation. The idea being that we are then using the same methodology for OGC API records as we use for OGC API features, basically. So we had a lot of work within this topic has been around mapping where the things like IHO electronic chart data and the metadata that exists within the service definitions and the catalogs that we already have, which have been around for years and years and years. How IHO's S100 metadata is laid out in the 19115 definitions that go to that, and creating an IHO model of OGC API record, of an OGC API record. All the UML and all the diagrams and all these presentations are all in our repository under topic 2. But broadly, that's our methodology. We create an IHO model for OGC API records. We can create bespoke extensions per product. For what we've done is we've basically created a metadata record that applies to electronic navigational charting data, which is land areas, sea areas, aids to navigation, topographic features, regulatory bodies, all these kind of things. Surface currents, so dense data relating to, as I say, surface currents. We've also done water levels and a couple of others as well. Once we've created this model, which is, as I say, is all documented within the repository through the mappings, we created a metadata feature catalog. And that basically is a specification of the structure of metadata for various categories of marine geospatial phenomena. We can create data, the metadata, we can then farm metadata from the existing IHO structures and create it under this unified whole, this unified structure, which can then be implemented as an OGC API record. One of the key things that we did within this project was it gave us the space to come up with a proper GeoJSON encoding of the IHO's general feature model, which sounds simple, but actually isn't. And we'll see that later on as we go. So this is kind of where we ended up, and I will demonstrate what we've done because it makes much more sense once you actually see it in practice. There's a website which is now open. I'll just find, right, so that's, should be looking, yes, okay. So we've used we took the easy way, and we used an existing tool to do our OGC API, and we focused really on the data content that went within it. So we used PyGeo API, which is fantastic, and it has an existing implementations of OGC API records. All that we had to do was create the data and the supporting documentation, which tells us what that data is all about. We were also assisted greatly by, and I must thank the Netherlands Hydrographic Office, Ellen Vos and her colleagues, who very kindly managed to expedite a request to get electronic chart data for the Netherlands. So we've actually populated our data using all the existing geospatial data sets for the official charts of the Netherlands. Now, we don't expose those actual charts themselves, and an added wrinkle with such data sets is they are actually commercially sold. So we certainly don't make that data available, but what we do is we make metadata describing those data sets available within our OGC API collection. So I'll show you some of those. So this is the any of you used PyGeo API, this is the HTML interface for it as well. You have a very nice, obviously there's all the JSON structures that you can get from it as well, but primarily there's this HTML, and we'll talk a bit about HTML later on. So yeah, so this is all the chart coverage features for the Netherlands electronic charts. As you can see, it's not also all in Northern Europe, since Netherlands has some charts in some rather nice hot places down here, but we'll focus on these. So these are the actual polygons that are included in the electronic charts for the Netherlands being exposed with their metadata through OGC API records implementation under using PyGeo API. We're doing the standard kind of 19115 type metadata fields. We've also derived a slightly more useful field within electronic charts for named places. So with each record, you also get any named places which are attributed to land areas, sea areas, or administrative areas. And the idea really was to show that you can make the metadata describe the nature of the data set itself using these bespoke extensions per product within the IHO family of data. So we've got those. We've also got, let me just find, we've also got some S111, which is, the Netherlands doesn't currently produce S111. The US does, and the US makes all that data available. We've shown this is their gridded water level metadata, and this also has types of current data, which is the which is a metadata field specific to that particular data set. So that's our OGC API records implementation. We've also implemented US ENC bounding boxes, as well as the Netherlands data. So it's great we've got the Netherlands data in there, and it seems to make sense. The PyGeo API works, the OGC API records bit of it also works. We've put it through the OGC's automated testing tool. I think the only wrinkle was we couldn't get the date time searching working, but we're going to iron that one out this week. I suspect we've not identified the proper date time field within each of the metadata records. But we can show this as an entire process now. We can say, look, there's IHO metadata, which is defined over 19115 under S100, which is, you know, the basis for all future hydrographic data products. And as those new data products come out for whatever they are, whether it's water levels, tides, there are meteorological ice data, there's all kinds of product specifications which are made under S100. We can define and create metadata models for them, which use the S100 framework, and we can expose them. We can expose metadata for it using OGC API records. So that was the $1,000 question. We can, with the $10,000 question, we can do this S100 metadata, and it will work for all S100 data products. It will work. You can farm data out of the standardized 19115 XML and expose it using OGC API records, and that should contribute to much greater findability and discoverability of this type of data. And marine data is notoriously difficult to index, to use, to search for, and there have been many attempts at doing this over the last 20 years. And the OGC API records structure gives us a really good way of encapsulating those. And So, you know, what's the so what of all this is, well, the goal of the research really was to bridge the gap between the IHO and the OGC communities using this. Our longer term goal for this is to provide a recipe to the marine geospatial community under the IHO of how to expose these arbitrary S100 data as OGC API web services, not just metadata, but also the actual core features themselves, should they want to. And most states have different desires and policies on what they expose and what they don't. I think we've been pretty successful at what we've tried to do. The API and the methodology works. That public accessible website is now open. We are, I'm engaged in a one-man battle with Google on indexing it at the moment, because they claim that some things aren't there that should be there. And the first indexing attempt we had, the Open API spec wasn't working, but that now works. And I'm literally waiting at the moment for Google to come back and re-index the site. There are some, it's interesting doing this because I think you learn more about part of the search engine optimization piece. You know, I want to Google, say, you know, my use cases, I want to Google bridges near some administrative area up in the Netherlands, and I should be able to see those kinds of results. I think once this site is actually indexed and all those HTML, because Google likes indexing HTML pages, once they do that and the sitemap is all uploaded to Google, we should get that. So unfortunately, I can't show that here, but I'm hoping that will happen in the coming weeks. That website's going to be up for about 6 months or so. We're just going to leave it going. We're currently involved in another OGC project doing open APIs. So as that develops, we may well re-engineer some parts of the data and keep refreshing it as the data updates. Our key takeaway is this kind of JSON encoding, GeoJSON encoding of S100 at a general feature model level rather than just a specific data product. We've built this model of S100 metadata, which we've expressed as the S100's general feature model, which gives us a really flexible way of constructing metadata for multiple S100 products. And our key takeaway is this kind of records implementation we've now got that works, that we can try and use for other things. And we can try and do this progressive search engine optimization. The JSON encoding is an interesting one because a lot of people sort of look at it and say, well, you know, why is that important? Well, it's important because S100 doesn't have, S100 only has GML, it has ISO 8211, which I'm sure probably not many of you are familiar with. And it does HDF5 as well for coverage data. JSON is pretty much ubiquitous in the world as the language for expressing complex data for consumption by web services, and it was a key one for us to be able to map what's in our S100 general feature model to something that is being expressed as GeoJSON. And I think that actually opens up a huge amount of public open source tools using open standards that we can say, there is data, you know, that thing on the right with the green text, that is S100 data. It just happens to be being expressed in a different encoding. There is work to do on that, but I think we've certainly done the bulk of it now. What's left is the recipe itself for marine geospatial custodians to say, how do I expose either this data set or this collection of features from this data set, or all these data sets, or just the identifiers from here? And I think we should be able to put a recipe together that says that's how you do it, using OGC API for the features, but also for the records and the metadata itself. There are some things we still need to do. S100's information types, which are shared non-geospatial features, which obviously GeoJSON's not very happy about because it likes things to have geometry all the time. We haven't done coverage data, so we haven't done any of the HDF5 data. And there's some tweaks to go on the types and things like that. ways forward for each of the individual communities. We did quite a bit of work. The Google search engine optimization piece is quite interesting. I think there is a way to go in terms of how we advise people to make the, how do you get your data findable by Google? But also the difference between that as a use case and I just need to keep a structured set of records that describes my data so that people, whether it's end users, whether it's public, whether it's automated systems, can find data according to the characteristics within it. The bit I really like about PyGeo API and APIs, and trying to answer this question whether APIs are intrinsically more searchable than static HTML pages, is this idea which I grabbed from the UNGGIM's IGIF, which we do some work on the marine context, and the spatial data on the web best practices, use globally unique persistent HTTP URIs for spatial things. And that's what OGC API records gives you, is a way of having Google searchable HTML pages for each of the elements within a collection of spatial data. And that idea about unique persistent URIs is very intrinsic to the idea of custodianship under UNGGIM, is a key thing. So the message for agencies who are responsible for data or have custodianship for data is, using an API, you can expose those things and have these very easy findable URLs to find each individual item within a collection. I think there is a way to go on how we define what collection an item is within our IHO community and how we make that mapping to S100. But I think we're a lot, certainly a lot closer than we were. Yes, my one gripe with PyGeo API is the HTML pages are all tabular. And I think the thing about tabular data is it reinforces this two-dimensional view of semantic content of data. So the data itself is actually complex, and S100 uses complex attribution. Complex GML uses complex attribution. Through using GIS, I think we get into this mindset that attribution of data is two-dimensional. It's a set of columns, each of which have values, and it's not. Spatial data has an arbitrary richness about it in terms of its semantic content. Feature names, so the names of things always have a language associated with them. You can give it a list of names. There's this tendency to try and flatten these structures and make these two-dimensional tables, which I think we probably should have a much more grown-up approach about now. Data isn't two-dimensional, it is multi-dimensional, and it is complex, and we need to find a way of representing that within our HTML pages, because I think that makes that whole indexing piece. It is important to have that richness in the HTML, because it's the HTML that is the strongest link for the Google search, which obviously is what we're all chasing after each and every day. Yes, so we are currently working on the JSON encoding of the S100 general feature model. That will open up these open API structures. We're working on how the information types, collections and items are defined, and working on this kind of recipe document. We plan to expose those ideas through the OGC Marine Domain Working Group at the next TC. So if anyone is at the next TC and fancies joining that meeting, please come along, and we'll be providing a kind of initial view on how that recipe works and some more examples from the Federated MSDI project, which we're currently involved in with the OGC. And I'm hoping that we will also then demonstrate that into the IHO's S100 work group meeting towards the end of the year, where we'll have these better ideas of how to approach things like S100's information types, potentially shared attributes or entities in their own rights, and also how better to equate the idea of collection an item which is core to OGC API. I guess my observation on that is that I would really like it if items could themselves be collections. I'd like a kind of recursive, arbitrary level of detail within OGC API, but I don't know whether that's a good idea or not, really. OGC API to me seems like this terribly two-dimensional idea of aggregation where you just have a set of items and they become a collection. But what I want to do is say that's a collection. In it, one of the items is also a collection. I want to see all the way down and access the API like that. Perhaps I can already. We didn't get to that level of detail. We're very interested in the CRS stuff in the previous presentation as well, and how we do that.
Jonathan, are you getting close to the end of your presentation?
I'm there. That's me. I'm done. Sorry about the last slide was my additional one. So anyway, very pleased to, and as Frank said, we're very happy to present some of this stuff to anyone who is interested in it, and we will we intend to take it forward over the next 6 months as the site is still up. Okay. Lewis says items can also be collections. Yeah, well, we're gonna do some exploration on that. I'm just reading through these from Adam. Flagging it with Ocean Info Hub team once the index is complete in Google. Yes, we will try and do that once we get the Google bit working. And the Decade of Ocean Science is absolutely in our sites, as is the linkages with the IGIF Hydro, which we're currently doing.
Peter would like you to present in the OGC API Records week.
Yeah, very happy to. Yeah, very happy to. If you get in touch, we'll arrange a time to do that. Sort of the marine view on OGC API records, and we'll report back once we've exposed it into the IHO community as well. A bit more.
Okay, so questions for Jonathan? Already had a few. I also have one. So the ISO standards are based on ISO 19115. Do you think your work can be generalized to other metadata standards that are based on ISO 19115?
Yes, I think it certainly can. What we've done is we've specialized 19115 and made what is effectively an IHOS 100 different formulation of that standard. I believe any marine geospatial data under the IHO's frameworks would adapt to the same kind of treatment. I think there's a way to go in describing how to do that, but we certainly could. But I think that the whole 19115 thing is an increasingly smaller part of what we call metadata. And metadata is obviously things you record about data sets that you then want to search for. It also seems to include search engine optimization for Google searches, but also I'm interested in how we adapt our concept of metadata to an API world, because I get the feeling that metadata really was more about static fixed data sets, and I'm interested in how we can use really start to live the API idea in that sense. But yes, I believe it could.
Okay.
And Ellen just commented about Inspire. Yes, absolutely. I think we should be able to do that for Inspire as well. That's something we can have a chat about.
Yeah.
So, may I please just confirm one thing? So, was the JSON encoding, the GeoJSON encoding, a representation of the ISO 19115 model, or did you enable the API to return XML encoded metadata based on ISO 19115?
No, we created a JSON encoding of S100 at a framework level. So we then expressed ISO 19115 within our S100 general feature model. So something like what I was saying was, in S100, for instance, things like, say, a description field, we have a totally separate structure for how metadata is described, and description is an XML string in S100. Now, actually, S100 has a completely separate thing under its GFM that says textual data, UTF-8. It's represented like this. So we actually created a JSON encoding of the general feature model, because then it applies across the board to any data product as well as metadata. So we don't produce the XML metadata at all, because actually the thing that we're most interested in is JSON, because it's web services. And actually, I would argue that 19115 doesn't have a good separation between, here is the XML encoding of it, here is the data structure that represents that 19115, and we need to focus on the data structure rather than the encoding itself.
Okay, all right, understood. Thank you.
Because 19115 is like, we were doing 19115 20 years ago, and it was when XML was going to save us from everything. We all use XML was it forever, and then suddenly someone went, hang on a minute, we can do this in this other thing with lots of brackets in it.
Yeah. Okay. All right. Thank you.
So are there other questions for John?
Showing my age.
And if not, I would really like to thank you as well, Jonathan, for all your work.
Thank you, Frank.
I'm really happy with the results.
Brilliant. Thank you. Thanks to everyone. It's been a great project. Really enjoyed it.
Yeah. So I think we might take a short 5-minute break and then move on to the last two topics. So I would suggest let's reconvene at 14:20 local time, so in 7 minutes time. So see you in a few minutes. If everybody's ready with fresh coffee, it's time to move on to topic 3, ease of implementation. So Ahmed Ayoubi, please take it away.
Yeah. So hello, my name is Ahmed Ayoubi, as Frank just mentioned, and I'll be talking about topic 3, which is evaluating the ease of implementation. So what is ease of implementation? So to begin with, the core belief of this topic is that geospatial data should be utilized by more than just geospatial experts, but it should be open to anyone with just general IT skills. And how you accomplish this is by lowering the barrier to entry. And in terms of the API, that means allowing the user to focus on their application over the data retrieval process. And to achieve this, you need to abstract areas of complexity. So in terms of the OGC features API, that would be an example of this would be the CRS, where you have a default and then more advanced users can specify a different CRS. Another important thing is to have intuitive design. So for the API, that would be something like the endpoint hierarchy, where it follows the structure that people are already familiar with, where an item is part of a collection and the structure just makes sense. And lastly, you need to have developer-friendly documentation. And with that, you also need to have discoverability of that documentation. And that also goes for the libraries that people will be using when using the API. So people don't usually just use the API alone. They usually use a suite of other tools that they make use of the API with. So this chart gives a range of the different possibilities that systems can fall under. So on the bottom left, you have systems that are difficult to use with limited value. And in the top right, you have systems that are useful and easy to use. And again, they achieve this by having abstracted complexity and intuitive design. So while implementing, I would categorize my experience in the following. So I would put OGC Features API in the category of being useful in my case, and it was also easy to use. Where the Convenience API had a more wider range, with some components being less useful for me, and somewhat complicated, and then other components being easy and useful. So there's a wide variability with Convenience APIs, and it also differs between API providers. So the client implementations that I worked on fell into three categories. So the first one is RED, which is the standalone implementations. The first one was an implementation of an algorithm known as simulated annealing. And for that, I used Jupyter Notebook and the OGC Features API. And then the other two are geofencing implementations or examples. And for that, I use JavaScript. And in the blue, you have web-based client implementations that use open source libraries. In my case, I used Leaflet.js. And in those implementations, I visualized the time series data in a chart. And then lastly, in the green, you have traditional clients. So in my case, I use QGIS. So for the first implementation, the one that used Jupyter Notebook, the problem that it's trying to solve is known as the traveling salesman problem. It's in that problem, you have a set of points, and you want to visit every single point in the lowest distance total. And right now, there's no good polynomial time algorithm for that problem. So people have approximations, and one of those is simulated annealing. So in this implementation, I used a package known as OWSLib, which took care of all the API request formalities, and it made it really simple and easy to use the API. So I can quickly show what that looked like. And in total, it took 3 lines of code to get the data that I needed. So up here is just the import statement for the package. And then right here, I make a request to the collection. And then beyond this point, I pretty much have the data that I need. Here, you can iterate through that collection. So it's really it makes the entire process really easy, and it lets you focus on the rest of the program. Another package that I used was GeoPy, and I used that package to calculate the distance between two coordinates. But that package was limited, and it also had inconsistencies. So with the OGC Features API, it would return coordinates in terms of longitude and latitude, whereas GeoPy expected them to be in latitude, longitude. And this inconsistency can be seen throughout. There's other packages that also have different ways of handling it. And that type of problem is one of the more harder ones to debug because a compiler or an interpreter isn't going to notify you about it. It's just through either experience or frustration that you finally figure it out. So for the standalone JavaScript implementations, again, it was a example of geofencing. So I can quickly demo what those look like. So in this case, this is the one that uses the OGC Features API, and the data set is for windmills in the Netherlands. So as you move around, you can it creates it notifies you that you're getting close to a windmill, and as you get close, you reach another threshold. You can move around, and in a meeting with Frank, he mentioned a use case where you could have a data set of benches, and as the user walked around in the park, they would be notified that there's a bench to their left or right. So for something like that, you would have speech synthesization. So as I get close,
you are very close to this lockup.
It notifies you. So although in this case it's windmills and it doesn't make that much sense to synthesize speech, the core components of this demo can be used in other cases. And because it uses an OGC Features API under the hood, it's as simple as replacing the URL, and everything else will work just as expected. So you get that code reusability. So this is the convenience API example. Again, it's very similar. The main difference is instead of thumbnails that the other one shows, it shows you the measurements. So if I get close to a location, it just pops up a chart and you get the measurements for a time. So if I go to a cluster, it shows you both of them. And again, the only reason I was able to reuse a lot of the components was because both of the APIs use GeoJSON, but that's not always the case. So one positive was that both of the APIs use JSON, which works very well out of the box, especially in JavaScript, by definition. And although people take that for granted, it is a major benefit. If you've worked with XML, then it becomes apparent why. So there is a lot of reinventing the wheel, which isn't great. So although other people have solved these problems before, they're not provided in a package that people could simply install or import into their project. They have to re-implement the same thing again. More specifically, this is the case with custom visualizations of the geospatial data. So although there are maps like Leaflet.js or other options, open layers that you can use, there's no package that offers you a more custom visualization experience, which would be good to have. So for the Leaflet.js implementations, again, it was just visualizing the time series data in a chart. This was done because the geolocations themselves didn't change over time. So Leaflet.js does support GeoJSON out of the box, which made it work well for both of the APIs, both the OGC Features API and the Convenience API. But it doesn't support OGC Features API as a whole. So this prevents users from taking advantage of all the affordances that the OGC Features API provides, and it simply boils it down to just the geolocations. And this can be fixed simply by having a plugin for Leaflet, because Leaflet does have a great plugin environment. So other notes, so Leaflet.js, it's very simple to use. It has great documentation and it also has a mature community. So if you ever do run into an issue, it's likely that there is a solution somewhere online, either on Stack Overflow or on their GitHub. And again, many of the benefits between the Convenience API and the OGC Features API, they're shared because both of the APIs use GeoJSON. But if the Convenience API didn't use GeoJSON, this would require a lot of pre-processing before you could pass it to Leaflet. And again, you get that variability with Convenience APIs. The Convenience API also required far more requests for around the same amount of geospatial data. And this is mainly just by the design of the API and the use case that it has for it, the intended use case. So it doesn't fare too well in general use cases. So just to illustrate what I mean by that. So in the two maps on top of each other, the one on top is the Convenience API, and the one on the bottom is the OGC Features API. So you can see as they're loading in, the Convenience API, the points load in sequentially, so one after another. Whereas with the OGC Features API, since it returns multiple items at a time, if you wanted to do that, it just loads in much faster and with a single request. So to look at the requests being made for the Convenience API, you can see over 100 requests are made for individual stations. And again, that's just because of how the API was designed. And again, you get that variability. So with the QGIS implementations, you get great responsive visualizations. It also works effortlessly with OGC Features API, as you would expect. For the convenience API, it does require Python, which is, although like Python is a beginner-friendly library or a language, it is the only option that you can use. So if you're familiar with another language, you can't really use any other. And an alternative to this would be to offer packages or libraries for the different languages, different development environments, and have it work with QGIS indirectly rather than as directly as it is now. There's also no good official resources on how to connect convenience APIs, so you have to do quite a lot of digging. And the editor itself, so to run the Python script that you need to connect the convenience API up, you need to use the built-in text editor, which can be very glitchy. So in here, I'm just running the script, and if you just wait a little, eventually it becomes unresponsive. And although it looks like there's a problem, this is actually the intent. This is the intended way it runs. It just freezes up, and there's no real good user feedback in the UI to let them know that it is working the way it's intended. Eventually, it does add the features to the map. And again, the script is available on GitHub, as are everything else that I mentioned. So some notes on documentation and practical discoverability. So with the OGC Features API, it lacks commercial solutions. And so this results in there being little to no advertising and having poor SEO. Search engine optimization. With the convenience API, it does tend better because there is a financial incentive to have more users. So with the current OGC Features APIs that may be offered by governments or nonprofits, you could argue that there might be a either direct or indirect incentive not to have too many users. And that's not the case with convenience API. And you can fix that by just having more commercial solutions. So you would have to convince companies to offer APIs. In terms of documentation, the Swagger Hub for the OGC Features API is currently incomplete. And it's also thrown together, and that's more specifically with the redoc. And both of those together just give off a perceived lack of effort. Although it may not be true, this is just what a user would feel when they first look at those web pages. And those web pages are linked. So when you search OGC Features API in Google, the first link that comes up is an OGC website. And then in that website, it links to those two other websites. So altogether, the first experience a user will have is one that gives off a perceived lack of effort. With the convenience API, it did have better documentation in my case, but that does differ depending on the API provider, if they even offer documentation. If they don't, you really don't have anywhere to go to. With the OGC Features API, you at least have the standards documents or the redoc or Swagger Hub you can fall back on if the API provider doesn't provide their own documentation. With the OGC Features API, you also get somewhat of a self-documenting nature in the responses, and this is a big positive. So just to illustrate what I mean by that. So here I make a request to the base URL, and then from the responses, I can pretty much get whatever other additional information I need without ever having to leave the API testing tool. So you just scroll through and until you find what you're looking for, you copy it, and then you can make a subsequent request. So it becomes very easy. So some other notes from backend developers. And these backend developers more specifically worked on topic number 1. I was able to interview them. And these were some of the pros and cons mentioned. So for pros, the first thing that was mentioned, that it's generally easy to use, which is something I agree with. They also mentioned that the standards documents were very informative. So in their case, they are working on the back end, so the server side of it. So it would make sense that they would delve deep into the details by reading the standards document. This is not the case for front-end developers who more rely on the documentation or the developer-friendly documentation. They also mentioned that JSON is highly preferred, especially because they were working in a TypeScript, JavaScript environment. And then for cons, this is more specific again to the backend. They mentioned that their frustrations with having to map CRS URLs to EPSG codes. Another thing they mentioned was that the links with the rel property self, they seem somewhat redundant because a user or an application should know the current URL it just made a request to, although it might have a use case that wasn't considered. And lastly, they mentioned that the CRS property and responses may be very large and redundant. So a solution to this would be to have a separate endpoint for CRS related information. And then that data that you get from that request, you can use in subsequent requests rather than having the CRS property in the current request that it is in, if that makes sense. That new endpoint would also have to be paginated because I think in their example, they used 5,000 as the number of options. So you wouldn't want to send over 5,000 different data points that aren't going to be used. So overall, and again, this is very subjective, but overall, they would rate their experience with backend development 8 out of 10. And for API consumption, they gave it a 9 out of 10, which I thought was interesting. So all the topics that I mentioned, it goes into more detail in the final report, which is available on GitHub. And there's also other topics that I mentioned in that report. But thank you for listening. And if anyone has any questions, I'll be happy to answer them now.
Okay, I'll jump in. Hi, Ahmad. Thanks very much for that presentation. Lots of great feedback. One point, just with regard to commercial solutions, there are quite a number of commercial solutions that implement OGC API features. I've just shared a link to the list of certified compliant products. But there are other products that are not on that list. For instance, ArcGIS also implements OGC API features. I think I think some of the lessons from your work will inform the further development of the various implementations. So thank you for your feedback.
Yeah, I guess I could be a little more specific. So with the commercial solutions, I guess I was more talking about solutions for general use cases. I think some of the solutions that are currently available, they're only known by GIS type people. So if you were to go on Google to search for a data set, you would see a bunch of convenience APIs, but you would never see an OGC features API. Or not, I shouldn't say never, but it's very unlikely. They didn't come up in my Google searches, at least.
Okay, understood. All right,
Yeah.
thanks.
Thanks, Kobe. Peter, you have your hand raised. Does your microphone work?
Oh, I think he typed it. Yeah, so the link with rel property equal to self, it was just something that was mentioned in passing, but there's definitely use cases that I guess they didn't consider. I just thought I should mention the notes that they shared with me.
Okay, so I was talking about Peter Fritanos.
Oh.
So can you dive a little deeper into that last bit about CRS? Peter is asking you.
Yeah. So when making, I don't remember the specific endpoint, but it's either the collection or the items endpoint. There is a CRS property that gets returned, and in that property, yeah. So in that property, you get a array of different URLs, so CRS URLs, I guess. And as you keep making requests, that data keeps getting returned. So instead of having that array of CRS options returned in those requests, you could have a separate endpoint for CRS specifically, where the user would make that request, get the information they need, and then take the CRS that they need and use that information in further requests if they need to. There may be a use case for having it in the request that it's in currently, with stateless, with the stateless systems that he mentioned earlier, or the other Peter mentioned earlier. But yeah, that's what I meant.
I see in the chat that Peter is going to make an issue for the API features rig about this. Okay. So Ahmad, you had the 9 out of 10 and the 8 out of 10 rating by the developers from topic 1. But could you also yourself give a rating?
Yeah. So with backend development, obviously I didn't work on that, but with the API consumption, I think I agree with their rating of 9 out of 10. Overall, it was very easy to use, and I didn't really run into any big issues that couldn't be solved. And overall, it was very intuitive. So I would give it a 9 out of 10.
Okay. As Lewis is pointing out in the chat that in a simple Google search, their PyGeo API implementation does come up.
I guess my question back would be, what did you search? If you search for specific URLs or PyGeo API, I'm sure it would come up, but if you search for general data that a user would search, it might not.
No, but mainly because we've set up a new API page on our website. So now if you search BGS API, you'll then find a list of our APIs, which will then take you to our PyGeo API instance and a few other convenience APIs we've got set up. But that's a relatively new thing. That wouldn't have worked 2 months ago. You couldn't have done that.
Okay. Yeah. That's also very, is that like a government website?
Yeah, so we're the British Geological Survey, yeah.
Okay. Yeah. I guess the request that I'm talking about would be more specifically the data. So say you wanted park benches. So if I search park bench data set, would OGC features API come up? I guess it would be more that case.
Yeah, okay, yeah.
Okay. So Scott points out that it's really valuable to get these ratings, and also one of our main research questions are these APIs easy to implement? Can be answered with a resounding yes. All right. So if you use the right library, 2 lines of code, easily reusable.
Yeah.
So that's a good takeaway from this research topic. And then a question from Peter Parslow: do people search for APIs or do they search for data?
I mean, I guess they can search for both. But if you want someone with general IT skills to use your API, they would most likely be searching for the data and not the API because they wouldn't know about the API. The APIs that people search for tend to be the more popular ones. Yeah.
Okay. So any other questions for Ahmed?
Just a quick comment that, I think this is great feedback. What we'll probably do within the OGC's architecture domain working group is to perhaps arrange a discussion where we can explore search engine optimization, and we'll provide the participants with your feedback, and that I think it will help us improve the APIs and that discoverability with various search engines. Thanks very much for the feedback.
Thank you. Thank you, everyone, for listening.
Yeah, thank you very much, Ahmed. I really enjoyed working with you. So great work. And the one downside to an online meeting is that you can't really hear the applause, but it's well deserved.
Thank you.
Okay, so let's move on to topic 4. Bert.
Yeah, thank you. Hi, I'm Bert Meerman. I'm from Purple Polar Bear, and I'm going to see if I can share my screen. Here we go, I think. We're from Purple Polar Bear, and we are a sorry, hold on. So we've been working on step number 4. Now we are a data collaboration company that is specialized in fair solutions to offer scalable industrial collaborations. So that's a bit about us, and let's move on to our topic. Now our topic is concerned with a comparison between a convenience API and the OGC feature API. This is the general question from the research topic that was asked by GeoNovum. And what we are going to do is we're going to take an existing convenience API and we're going to investigate the cost and benefit of adding the OGC features API to it. Now, so this is one way of approaching it. The other way is if you take the OGC features, an application that has the OGC features API, and then add a convenience API to it. But we're not going to do that. We've chosen this approach. The convenience API that we will be using is called the Digital Delta API, or DD API, with the Aquo standardization. This is an API, is a convenience API that is very well known in the Netherlands and is used for, among other things, hydrological data. It is primarily used with hydrological data in the domestic waters, so that would be rivers and lakes and all that stuff. However, it is also used to some extent in the marine parts of the water management in the Netherlands and hydrological data in the Netherlands, where although we will be focusing on the domestic water industry. If you have any questions, by the way, ask them throughout the presentation. And although I cannot see the respondents, I'm hoping Frank could then just point out that somebody is asking a question. Otherwise, we have to go back later on. Okay, so we've been doing it using 2 projects. The first off is Gove. Gove is a project that was already available in the testbed of GeoNovum. It is a Go implementation of the API features. It is an application that contains a full web server that serves OGC API features using either a Geo package, SQLite, or a Postgres database as its data source. It was developed by the Kadaster, which is a Dutch organization responsible for, among other things, pointing out where, for example, your house begins and ends. So it's a government organization, yeah, so we've been started working on that one. And I want to give a shout out to the people from the Kadaster who have helped with during this research topic. So thank you, Wouter, Anton, and Roel. And what we have done is we have extracted the OGC API features part of it. So we kept the whole Postgres thing and the whole SQLite thing. We kept that in place, but we extract the OGC API part out of it. I'll explain later on why we did it. And this we put in a library called the Go OGC API library. Locations, by the way, of both of these can be found in our topic documentation, which is also kind of like the style of the rest of the presentation. We'll simply follow the topic documentation, which is currently in review state, as we are still waiting on one of the participants to give a go on the reviewing. But if you go to the topic 4 branch, you can already check it out. Now, so the goal here is to discover the usefulness on one hand, which is good stuff, and the feasibility, which are like a problem stuff on the other hand, of combining, of providing these two APIs for a specific system. We also go a little bit into this library thing, and the reason why is because the feasibility of adding Node.js API feature implementation depends a lot on whether you're going to build the entire thing from scratch, which is a lot of work, or whether you have a library that is just waiting for you to be used, and which takes away a lot of the difficult and complicated things, and also the tiresome things and the nasty things, and just allows you to very rapidly implement it. So this library thing is crucial, as it will give it will very much change the whole cost aspect and the effort aspect of adding the OGC API features to the implementation. Okay, now the scope is scope and our constraint. So again, the angle is that we take an existing API and ask ourselves, is it worthwhile to add the OGC API features implementation to it? We do not go the other way around of starting off with the OGC API feature implementation and then adding a convenience API. And also, again, the convenience API will be the DD API with Aquo used by, which is, by the way, used by like dozens of organizations, literally dozens upon dozens of organizations in the Netherlands. So it's large. Now we make the comparison by looking at systems that contain location data. However, the DD API with Aquo is essentially about time series and measurements. Now, of course, you measure somewhere, so it contains location data, but much more important is it contains measurement data. So data on, let's say, water levels or on the flow of water, but also concentrations of certain chemicals in water, or the amount of fish at a certain place during a certain time, or the amount of birds. All that stuff is all inside the DD API Aquo standard. So measurement data, we'll get back to later on, but that actually is quite an essential thing, which is out of scope of this topic. However, we have came up with some very interesting results nonetheless. And we will demonstrate the add functionality that becomes available using only the QGIS client. We assume that you understand that if it works on the QGIS, it will work under a lot of other clients, and you kind of like expose the whole functionality of applications and functions and features that's available inside the geo community to, in this case, this DD API community, if you manage to do that. Okay, now the approach is to delve to the so we start off with the Go thing, which exists in the existing project, and we're going to pit it against the DD API thing. Now, the usefulness will be approached in two different ways. We will show that if you do this, you will have some new functionality. We'll basically do it by showing an image of the QGIS desktop that it renders features. We also look at the usefulness in terms of business value. We do this through an expert interview, where we interview John Maaskant from IHW, and ask them what he thinks is good or great about the addition of the OGC API features specification. IHW, Informatiehuis Water, is the official body, governmental body in the Netherlands that is responsible for Aquo, for the DD API, and essentially responsible for all standards with respect to water and everything around it domestically. There's also IHM, where M stands for marine. This is a different organization, and that is more concerned with marine data, though the two know each other and work besides each other, of course. Now, the reason for the expert interview is simply to fully implement the whole thing and keep getting it running in actual working in production environment. That would take too much time for this research topic, so it's simply not feasible time-wise, as these things take a lot of time to do. With respect to feasibility, we'll be taking a look at again any concerns from the expert interview, plus monetary concerns, where we will be looking at the cost of initial development as well as the cost of maintenance. So we will include maintenance in our calculation. Okay, now the method used. So here's the first thing, and you can actually see the image. If you have a convenience API, then as pointed out in the previous presentations, tools such as QGIS won't be able to understand it. Yeah, they don't know how to do it. So you're going to end up with an empty page if you try to run it in QGIS. If you add the OG API features, implement an API to it, QGIS will be able to understand it. In this case, you see locations being rendered in the QGIS viewer. Now, this seems pretty obvious, but the important thing here is to realize that if you have an existing industry that has an existing set of rules, for example, the one from the S series from the first presentation, then if you add the OG API features implementation to it, all of a sudden, tools such as QGIS or any other tool that can use this kind of thing now become available to be used immediately. So all those menu items here at the top, they contain a lot of things you can do. They contain the Python thing as well, as mentioned before. And all of these things now become available once you add the implementation to it. So that's a benefit. This benefit, however, is purely functional. We don't know if it really has any business value, but that's kind of like the benefit. So this is the thing that we want to show here. Now, the expert interview. The expert interview came up with a couple of very interesting points. And we asked them what's the benefit and is it feasible? And we asked the feasibility question from multiple points of view. So we asked it economically, is it feasible given the required investment cost? We also asked it socially and organizationally, that is it possible? You have an existing industry, there are dozens upon dozens upon dozens of players present in that industry. Is it going to work to add this API to it? Are people going to use it, or are people going to resist it? How is that going to work out? And we also asked if there are any cultural constraints or boundaries or considerations when introducing the OG API specification to in addition to the DD API thing. Now, for determining cost, as I said, we take on the initial development. For this, we took a couple of assumptions, which we consider to be reasonable assumptions. First of all, we assume that a developer codes about 900 lines of code per month. This is an average for business systems. We assume a total cost, so it includes everything, including the kitchen sink, for development costs to be roughly about, on average, 10,000 a month euros. And we took a minimum and maximum range of 2/3 of this amount, and the maximum range is 3/2 of this amount. So that's 67% and 150%. With respect to maintenance, we assumed 10-year maintenance time, and we assumed 15% maintenance on the total code size per year. So this is a total of 150% maintenance cost. Of course, you can you can take the report and take other assumptions if you think these assumptions are off, and you can run them, and then you can easily get other numbers, and you can make your decision based on that. Okay, the library. So we designed this library that should take care of basically all the nitty-gritty stuff concerning the implementation. The library has two very important design goals. These are the leading goals. The first one is it should be easy to use. And with that, we mean that if you are, so to speak, just a developer who just has a couple of location things and they want to show it, you should be up and running in no time. You should not go out there and read OGC implementation specifications, because that's just way too much. It makes it very, very difficult. So you should be able to get yourself going very, very fast. Now this is especially interesting if, well, let's say you're a retailer and you have like a couple of hundred shops in the Netherlands or somewhere else. You should be able to get a map and get it out there with very little effort. You don't need all the fancy things that are present in the API. You just need to basically get some features out there. So that's the easy to use design goal. The other one is that it should be easy to expand. So if you are a more sophisticated developer, if you have like large data sets, or you have a lot of other stuff you want to show, or you want to show your data in other data types than just application JSON. So we use JSON and HTML as the default ones, but you also want to add it in GeoPacket format, for example. You should be able to do that. So if you want to expand, if you want more, you should be able to do more, and not like kind of like have to rebuild half the API before you can start doing those things. So those are the two design goals. Now the design itself, it is actually designed to support essentially all the OGC API specifications. So the thing is built around a single engine, which you mount somewhere, and then you start adding components to that engine. In this case, the components added are the core component, which contains the landing page, the conformance page, and the API page. The other component added is the features component, which contains the collection pages and the some collection items pages, so the feature pages, so those four. It is, of course, understandable that in the future, somebody may write, for example, a tileset component, which allows you to expose tilesets as well. And actually, I heard some people already starting to talk about wanting to do that. If you, by the way, if you want to do only tilesets, so kind of like a WMS implementation, you would then use, the engine, you would use the core components, and you would use not already implemented, but you would use a tileset component, and you would omit the whole feature component. If you do not include the feature component, you do not have features. So this is the design, and again, you can see here now that it's again very easy to use. I need an engine, I need some core stuff, I need some feature stuff, and then you can implement the features thing, and you're done with it. But if you want to expand, you can do it into all sorts of directions. I use this example, so I think I've demonstrated my screen, so I should be able to show you a bit of code. I'm not going to show you a lot of code, just a little bit. Oh, I'm sorry, this is the wrong one. So over here. So what you see here is the things in the code blocks are essentially the things you need in order to get the whole thing running. So you need the code at the top. You see the mounting path, which refers to the fact that you need to understand the paths. The library actually uses the entire paths. I'll get to that later on. And in the bottom, you see the thing with the interface. You have to provide these 5 functions in order to supply the system with a service that serves features. So these are no collection, features, feature, no what comes out of the API specification. Okay. Now, with respect to the results of the implementation, if you take a look at the results, the end results, we see that this is relatively easy to use. You saw just a couple of bunch of lines of code, which are very simple. You can just copy paste it and the thing runs, and you need to implement those 5 things. And there's very little way to get around those 5 things. Now the ease of expansion design goal, the features part is independent from the main engine. So you can omit it, you can implement a tileset as thing or any other part of your APIs as thing, and run it instead or in addition to, and it will work. The library contains default JSON HTML templates, but you can change them. You can put other templates in there as well, and you can use completely different content types. So in that case, we think we kind of got the whole ease of expansion covered there. Now, with respect to implementing the specification library, we would like to point out that the developers actually have experience implementing an OTC WFS 2.0 standard. We found the following subjective experiences with respect to library development. So the whole collections and features part in and of itself, that part is pretty straightforward and pretty easy to do. The thing that is tricky is the linking part. This was mentioned in a couple of presentations earlier, that the linking with the relative URLs and all that stuff, that's a bit tricky. Now the library does take care of that. So you just say, this is where I host my server, and it will take care of all the links and all that stuff. It will do all that stuff for you. You don't have to do any work there. It's done by the library itself. But what was tricky to implement? The HTML implementation, so there's a mandatory HTML implementation. Well, we didn't really find it relevant because our use case, the people who are using this, we're going to be using it. For our use case, we'll be using business systems that will simply go for the JSON. They will never render the HTML. They will go for the JSON, and then either run things like a QGIS client, which works with the JSON, or they run expert business systems, which work with the JSON and then make calculation and then expose the end results using their own HTML pages. We also found the OpenAPI specification to be quite a lot of work to implement. It's quite tricky, and we don't really understand the added value in that sense, given that if you want to use it and you know you're going to be using an OCAPI features or an OCAPI implementation, you know how the entire thing is built up anyways. I mean, you know the specification, you know how the thing works. Now QGIS isn't trying to figure out how the OpenAPI thing works. It just runs with it can just run with the whole. I think it doesn't need to. It doesn't need to use the OpenAPI thing because it knows where the collections are and where the features are and this kind of thing. So we didn't find a lot of added value in the OpenAPI part, and there was some stuff to implement it. Now, in comparison with the WFS 2 standard, we've been asked to make a comparison because we've implemented both things. We found those two things, so the links, all those links that are everywhere, that was a bit tricky and a bit cumbersome, and the OpenAPI specification was also a bit tricky and cumbersome. A couple of issues with the library. So rounding up, the library, we have passed it through the OTC Team Engine test suite to be specifically OTC API features. It did not completely pass that test suite. A couple of findings there. Now, first of all, we found response to be a bit cryptic. So it said the thing we hanged on was it said that it cannot find the conformance page. However, upon manual inspection, we have a conformance page. It's there and it looks good. It looks great. So we have no idea why it's saying that. Due to the cryptic messages that the Team Engine gives, we try to look into the underlying scripts that are running the test. So these are so-called, I think they're called CTLs. However, we couldn't find the underlying CTLs. So we weren't able to reproduce what it was doing and why it came up with the idea that we didn't support a conformance page. And this had the whole experience with the Team Engine to be a bit cumbersome and frustrating. It actually cost us quite a lot of time, and we didn't really have the idea that it was adding a lot of value. So you can kind of see this as a problem. So it kind of, because it hinders adaptability. We just dropped it. I mean, the thing works on the QGIS, so why go after some weird message from Team Engine? Another thing is that there are numerous references on the web towards OTC API libraries, and the Go OTC API library, this library, is not present on any of those lists. We have not added them. So those are some things about the library. Okay, with respect to the benefits. Now, the first benefit you've already seen, all of a sudden, the full functionality of tools of geo tools such as QGIS become available. This is a huge benefit. The second one comes from the expert interview. Now, during the expert interview, John said the couple of following things. First of all, he said that the addition of the OTC API features implementation will provide huge added value to the community. I have to mention though that the water community in the Netherlands uses a FAIR system, a FAIR metadata layer, and this allows them to have like one way of approaching all the data sets, and they only need one. They only need to upgrade one part of that in order to expose all the DD API data via an OGC API implementation. So this means that economically speaking, there's a minimal investment, because although it is driven by dozens of different systems, the FAIR metadata layer allows them to add just one component to it, basically this one, and all those systems will then output their data in OGC API features format. So that's economically. Social and organizationally speaking, as I said, there are like a dozen organizations who build DD API systems, so they've invested extensively into this API. They will, well, they don't want to see their investment go up in vain, so they will. There will be some. It will just take some time to implement the OGC API specifications. Also, the DD API Acco specification is more extensive and larger than the OGC API specification. Culturally, lastly, we want to stress that the governmental culture in the Netherlands is one that is decentralized or federated, and EHW is the formal legal owner of the DD API specification, of the Acco specification as well. These are mandatory specifications. However, culturally speaking, they cannot dictate changes to the participants in the industry. So any compliance and cooperation must be achieved through extensive collaboration, which in Dutch called polderen. And as such, implementation and adaptation have to go at a small scale and then slowly be expanded, and updates and development of new systems must be used as opportunities to implement the OGC standard. So that's a cultural point that was given by Jean. Okay, now the cost. The cost, now I'm not going to go through all the numbers. I mentioned the assumptions, so that's I think sufficient. But I'll give you the rough ballparks. The development cost of a library such as this one ranges between roughly 10 and 30,000 euros. To implement from scratch, we're looking at like 10 to 20,000 euros, just development costs. Total cost would be 20 to 50,000 euros for an implementation from scratch. So an implementation from scratch is quite, it's somewhat expensive. I mean, if you build a system that costs millions, you can do it. But if you build a system that costs like 100,000 or 200,000 euros, and all of a sudden a 20 to 50K, it becomes significant. Using the library, however, you can get development costs go into the range of a couple of thousand euros. Total cost can go up to stay under 10, so somewhere between 4 and 8. So using the library, it becomes economically very, very feasible to add the OGC API features implementation to an existing system. As well, you will probably be done with like 10K total cost, perhaps 20, but that's it. So that's very, very affordable. This leads to the following conclusions. Now, implementing the library is considered to be quite straightforward and can be done with minimal cost. So this is an affordable and easy way to use for many, many developers. I'll show you a bit of the code over there. There is no formal specification required. It's a very simple thing to do. There actually is a very high value in offering two APIs. As I mentioned in the when we're discussing the interview, the existing industry has an existing API and they want to stick to it due to investment cost made. However, the OGC API implementation can really open up an industry for innovation from outside. So that's considered to be a very high advantage. Now, the OGC API features is already implemented by many major GIS clients. There's all the link with the list from the OGC webpage. So there's a lot out there already. You can use it. Building an OGC API feature implementation from scratch, however, that is relatively expensive and it requires in-depth knowledge of the OGC specifications. And also, we don't consider OGC Team Engine to be a very user-friendly system. Now, keep in mind, you only need OGC Team Engine if you implement a library or implement it from scratch, but we don't consider it to be a very user-friendly system, so that hinders compliancy and it raises the bar for adaptation. It should be able, yeah. So yeah, so that's it. Thank you for your attention. And are there any questions?
I can, if I may, just
Yes. Go ahead.
comment. Hi, this is Gobi. Sorry to hear about your experiences with Team Engine. So the specific two issues that you mentioned there, the first one was with regard to discovery of the conformance resource. So it sounds from your description, I understand the issue was most probably because the landing page probably did not identify the link to the conformance resource.
No, it did.
When
It did everything. It worked completely as it should. It did show the link. That's the problem. It was impossible for us because we have the original Gove implementation and we just looked at the JSON files side by side and we could not see any difference. Okay, so just to help you troubleshoot, I don't have access to your implementation, so I cannot give you a definitive advice, or I cannot give you definitive advice on what to look at. But when we say link, we mean link relation and the URL. So yes, those have to be exactly as specified in the standard. I'd be happy to have a look at your service and to provide you with some clearer guidance. The other thing is, the other comment you mentioned was CTL. So Team Engine, the CTL part of Team Engine is very limited. The actual executable test suite for OGC API features uses TestNG, which is Java. Okay, but then I couldn't find the Java code. Okay, so I mean, for what I'd recommend is if you encounter any difficulties with Team Engine, please contact the site forum. I'll share the email. There are usually lots of developers very happy to provide feedback and guidance. So I'll share the email via chat, and please feel free to get in contact, and we can help you to troubleshoot the issues. Yeah, thank you. So I've sent the two links. So the first link contains library. The second one contains the program. My gut feeling is the only difference I could find was that the Gove server is hosted on /, so directly off the root, and we have served it off /package. Now, besides that, the JSON is identical. So there is no, and the Gove system, by the way, Gove does go past the Team Engine thing. So there's yeah, so that's kind of like it. And there's no way we can we can otherwise figure out what goes wrong because it serves the exact same content. Okay. All right. Thanks for check out the program thing. You can just check it out. You do go run. If you have Go installed, you can just go run. There's a way to do it, and you can look at it, and you can look at the /package. You can see the JSON responses, and you can run them through Team Engine. It's actually changed a little bit in order to make it able for the Team Engine Docker instance to be used immediately and very easily. Okay, thank you. Thanks for the feedback. Thank you.
So Bert, maybe one more question for me. Right, so you also have some experience with implementing WFS and WMS. So how would you rate those in terms of cost compared to OGC API when starting from scratch or doing it with a library? Yes,
I think the most important thing is how much do you want to implement? If you just go for WFS with bbox support, no querying, no sophisticated stuff, and you can go to the get capabilities, just say no to every question asked, basically, or false. The costs are actually a little bit lower because you don't have the links stuff going on all the time, and you don't have the open API stuff going on. This is sufficient for clients such as QGIS to completely load the data set into their main memory. Now, given of course that your data set is not humongously large and all that stuff, but then QGIS can just load it and you can work with it. And for most cases, this is pretty good. So I'd say that the WPS is easier in that way. Of course, you start implementing the stored query stuff, then it becomes much more complicated, much more difficult. But if you just go for, here I've got a bunch of features, that's enough for those kind of tools to understand it and to work with it. And I would say that it's actually a little bit easier due to all the links present and the open API part.
Okay, thank you. Any other questions for Bert? And if not, I would like to thank you very much for participating in the testbed. So I'm very happy with the results you achieved. So thank you very much. And now it's time to move on. Yeah. Oh yeah.
So one more thing I forgot to mention is that during the running of the research topic, the Informationswater, they got so excited that they're actually looking forward to adding in production the OGC API features to the DD API infrastructure world using the FAIR methodology. And this means that all the DD API systems present, which is everything with the domestic water thing and air quality, water quality, ground quality, as well as some of the marine stuff. I'm not quite sure how much it is, but some of it, at the very least, will then also be available, at least for internally available for OGC API usage. So this is now being considered a very, very interesting option. That is very much on the table, and we're looking at ways to move this forward.
Okay.
So they are looking at ways to move it forward. So that's a very nice thing, I think, very nice result.
That's a nice thing to end this with. So again, thank you very much for your work on this testbed. And now let's move on to the final topic. Bill, can you take over?
Hello, everyone. Thanks very much, Frank. Yes, I will give a talk on the work that we've been doing for research topic 5. So I will just share my screen. So yeah, hello everyone. My name is Bill Roberts. I'm from a company called Swirl in the UK, and we work primarily with government organisations and help them with disseminating data. And most of the time we're doing that, making use of the linked data set of standards. So this is a set of standards produced by the World Wide Web Consortium that is based around using the architecture of the web, and in particular using a set of standards around RDF, the resource description framework, to represent data. And it's often quite powerful and useful for government data, particularly where you want to try to integrate things from different layers, from different sources. And in this work, we were interested in how we might be able to combine some of the things that we're doing there with the OGC API features to try to provide an alternative way for accessing that data that would be more familiar to users of spatial data in particular. So our objective at a high level of this work was to find ways to improve the interoperability of spatial and linked data. And I guess a lot of people on this call already know quite a bit about spatial data, and I'm sure some of you are quite familiar with linked data as well. But just for the people who might not be, very briefly, the principles of linked data are that you give all of your things of interest an identifier in the form of a URI, and you can make use of the internet domain system as a way of ensuring that you can create globally scoped URIs, which can be useful. And also it provide the principles of linked data provide a mechanism for you to use the web to look up that URI as a standard way of getting information about it. And there's various different ways that you can deliver that information, but usually that makes use of the RDF standards as a format for delivering the data. And I guess the key thing about linked data is it's a way of making data that you can link to, if you like. So it's a way. The principle of it is that everything that you do should have a URL. There should be a way to access individual data points or collections of data or subsets of data. And one of the things that we try to use that for is to make data management more efficient, in that one group of people can take responsibility for managing a data collection, and by exposing it through this kind of approach, then it becomes easy for other people to use that. Obviously, there are other ways to do that too, but that's one of the things that we try to do with this. And the work that we've done with the GeoNovum testbed has made use of data that we were already working with in the context of work we do with the Environment Agency in England. So for them, we develop and run a number of applications and help them to manage a load of data collections. And so we pick, and those are already available in RDF format, and we can get them easily from existing databases. So on the one hand, it was easy for us to get data that's already prepared as linked data, but also we know from working with these of some of the applications that the users are interested in, and the kinds of things that they want to do about making connections between different data sets. So we chose 4 data sets that were in use amongst parts of that work. So one was a collection of monitoring sites of ecological sampling data. So these are, in spatial terms, these are all, the monitoring sites are point geometries. We used water bodies, which are a set of polygons and is a kind of physically based set of management areas that the Environment Agency have to divide up the country into units that have common characteristics. We picked up the set of flood defence assets. So these are parts of the country's flood defence system. There's all kinds of different things, but we just picked the flood defence embankments as an example data set. And those are typically line geometries. So this is a bit of raised ground along the edge of a river to reduce the risk of flooding. And because a lot of environmental and flood-related activity involves local government, the so-called local authorities in England, that the areas that each authority is responsible for is something that's of wide use. So that's another set of polygons. And one thing about the local authorities that had some interest there is that data set is managed by a separate organisation, whereas the other 3 were things that were used within the Environment Agency. So this is a copy of a diagram that was made by Franz Knibbe years and years ago at a workshop that was held in London that brought people from the OGC and the W3C together to think about this question of the communities of users that are familiar with the sort of set of web standards and linked data and RDF, and the set of users who are familiar with geospatial standards and GIS and WMS, WFS, all this kind of stuff. And at the time, it was felt that those 2 groups were largely distinct, and often people in one group knew very little about the standards and tools and approaches of the other group. And it was recognised that there's potentially a lot of benefit by trying to bring these things together. And what we're doing here is really an example of that, and something that that's been going since that workshop. There's been a lot of activity to try and investigate this kind of thing, and this feels like a natural extension of it. And one of the things that came out of this workshop in London back in 2014 was the Spatial Data on the Web working group. And that came up with a set of best practices as one of its outputs. And one of the things that, amongst those best practices, is this one of use spatial data encodings that match your target audience, or more broadly, just offer lots of different ways of getting data because different people want different things. And that was quite similar and inspired by this other thing from an earlier set of work, which was just the data on the web best practices. And that similarly, again, suggests this relatively obvious thing of provide data in multiple formats to suit the needs of different groups. And while there's some extra effort for a data provider in doing that, then it's a manageable amount of effort, and it can greatly increase the use of your data. So one of the things that we were trying to, the thing that we were trying to investigate with this was, can the OGC API features be an additional access option to the linked data collections that we already have? Excuse me. And within that, one of our key interests was, how do you make links between different things? And that includes, how do you make links between one item and another item that has some kind of relation to it? And also, how do you make links between two different representations of the same item? So with that idea that you want to be able to offer different formats for representing some data of interest, if you're looking at one of those representations, how do you find out about the other ones? So I'll skip out of my slideshow for a minute and just kind of show you some of the things that we've done to try and illustrate that before discussing some of those aspects. So this is a simple web application that we made just to test our API implementation and to illustrate some of the data. And so this is a part of England. This is Liverpool in the top left corner. So these markers are the monitoring sites. The kind of blue outlined areas are the water bodies. The purple or magenta outlined areas are local authority boundaries. And there's a few down here, if I zoom in a bit. These green lines are flood defence embankments. So this is using the leaflet library, the leaflet JavaScript library, and just making calls to the API to retrieve the data, getting a GeoJSON response and drawing it on a map. So one of the aims of using a standard approach, I guess, is that existing tools can easily consume it, and that was certainly something that we found with this. It was very little work to make this this demonstration. I mean, it's not a very polished demonstration, but the core of it was quite easy to do. Just to mention that I'll go back, that our API and this data is hosted on a website, geonovum.publishmydata.com, and you can see the main collections here. We've got one for water bodies, one for embankments, one for so-called BioSys sites. BioSys is the name of the database system in the Environment Agency that manages this particular collection of monitoring data, and one for local authorities. So I'm just going to talk about how we actually went about doing this. I'll try and find the right tab. So there's a GitHub repository, github/swirl/OGC API prototype. So if anyone wants to have a look at how we went about this in detail, you're very welcome to use this code. It's openly licensed. But the essence of it was that we used an open source graph database from the Apache Jenna project called Fuseki. And there is a version of that has an implementation of the geospatial query language, which allows you to extend the Sparkle language, that's the normal way of querying RDF data, to include some spatial functions, all the kind of standard functions that you would expect. So we picked up this database, loaded in our data that we already had, and built a simple API on top of this, which retrieves the data by a Spatial query and formats it and delivers it using the OGC API. So I don't expect people to want to read all the fine details of this, but if you're at all familiar with Spatial, you'll kind of recognize what's going on here. This is one of the queries for the BioSys site collection that just queries the RDF database to get all the things which are of type BioSys site, and optionally limits that to a bounding box based on a geospatial function to look at the geometries of those items and compare it to a bounding box. So the essence of this is very simple. Obviously, kind of getting all the bells and whistles of the specification right takes some work, but the principle of it was all quite straightforward. So I will carry on with the presentation. So the thing that we were interested to do by using a system like this is that because we have the data as linked data and we're storing it in a graph database, we can use that to supply the people that want to consume the linked data, and it can power applications that have already been developed that query that data and support users to explore it. In many cases, those data collections have a kind of custom API for the particular collection already. And all of those things have an element of spatial data in them. So you can get that spatial data by querying the RDF aspect and retrieving that. But by adding in the OGC API, we wanted to make it easy for, if you like, spatial data users, so people who are familiar with standard sets of standard tools of the spatial data world, to make it easy for them to use it too. So, for example, we've been talking about calling OGC APIs from QGIS. That's relatively easy to do, and it was certainly very easy to populate a JavaScript web map using calls to the API. So we're providing essentially equivalent data in different standard formats and protocols. That principle of offering the same data in different ways to different people, and try to find ways that we can simply help users find the option that they like best. So I guess I've talked about this already, just shown that the links to GitHub and to the hosted versions of this if you want to see the details. And as a reminder, the things that we're trying to investigate we're particularly interested in this issue of linking between items. So there's two kinds of things here. This is an example of how you might want to link between different representations of the same data. So supposing we have a local authority in our OGC API. If you're staying within the set of OGC standards on the left side of this slide, then one of the links that you're going to be interested in potentially is from an individual local authority to all of the collection of other local authorities, and of course vice versa. You might have the collection and then want to see all of the individuals. But also, we would, in this situation that we're working in, we'd want to link from the local authority in the OGC API to the linked data representation of that. And then in the linked data world, then we maybe have other kinds of connections between things. So we might have perhaps a more extensive set of properties or attributes about that item, or we might link from one entity in the linked data collection to other kinds of related things. So I can just show that quickly in practice. If I can find the right slides, the right tabs. So yeah, so this is our collection of local authorities. If I go to the list of local authority items, so this is the first one. It's a local authority with this code number, and we have some properties of it here. But in the links section, we've taken the approach of using the link type of about with the existing link data URI that we had for the thing of interest. And so one thing is then if you follow that link, then that takes you to a web application that already existed that can give you more information about that based on the link data representation. So down at the bottom of this web page, you can see all of the things that we know about that local authority in a linked data structure. And when I was talking about one of the things that you can do is obviously link this item, a local authority, to other related things. Then, for example, this map on the right is showing all of the so-called output areas that are inside that local authority. So these are small areas defined by the statistical authorities for delivering statistics. So we've gone from OGC version of this data to a linked data version of the data, where we already had some additional information that we could use. So this kind of relationship could be in the OGC data too, but what we're saying is that each kind of side of that slide doesn't need to be a full a full complete equivalent of the other, but there might be some things that are more convenient to have in a linked data form and other things that are more convenient to have in an OGC API form. And if you, somewhere here, I've got a tab. Yeah, if you want this in an RDF format, then you can get that. So that kind of linking between representations and then kind of going off to follow links in the other world, if you like, is one possibility. And the other option that we were interested in is this kind of linking between one item and related items. So the example we've taken here is that in the for the monitoring sites, each of those is defined as being inside a water body. So that's something that we can represent in the OGC API. And also, once you get to that water body, you could then potentially go off to linked data versions of that too. So just to kind of show what that looks like in the implementation. So we have a set of these monitoring sites, and one of the things that we have in the link here is we've used a kind of a related link to this other item in a different collection in the system that we've got. So I will click on that, and I'll just close up the geometry because it's a bit big. So then we've got the API response for this particular water body. So, and then once you're there, we've got an about link to its identifier, so you can follow that, and it takes you to an application that the Environment Agency has to provide data about these water bodies and various things about how they're classified in terms of their ecological status, and you can download stuff about plans that are in place to try to improve ecological status and all that kind of thing. But one of the things that I guess we've found is that the OGC API has a well-defined approach to making links to different things, but it's based on the principles of HTTP link headers. And if I understand correctly, the recommendation is that you should use relationship types that are in the IANA registry of link types for HTTP. And those are, I guess, relatively limited in the richness of their semantics. So they've got some really important ones. Like they've got the self one to kind of show where this current representation came from. This about one is useful because we can say that that's this is a representation of a thing with a particular identifier, and we can link to collections. But also just an experiment, it's obvious that you can have URIs of other things just as a value of any of the properties. And so one of the things that we did here is that each of these water bodies in the Environment Agency dataset is linked to the catchment that it falls within. And so we can have a catchment property that links off to other stuff. So one of the things that we've been experimenting with, and I think we possibly don't have a definitive answer, so I'll come back to this a little bit later, is what are the pros and cons of using the links headers or just using properties within the response to represent some of these relationships. But in any case, this was like a simple structure to help us make links within the OGC world. And then obviously once you follow that link, you can decide whether to go further in the OGC representations or to jump out into a linked data version. So one thing that we haven't yet done is to make any additions to the existing linked data representation, but something that we would certainly intend to do if we were using this in an operational environment would be to make the link back from the linked data version to the OGC one. So it would be straightforward to add another property to the linked data representation of, say, this water body to say, if you want this in OGC API format, here's the URL that you go to get that. So yeah, I guess to summarize, what did we learn through this project? Well, we found it really interesting and enjoyed the working with the OGC API, and also enjoyed the sessions with the other topics and learning about what people are doing with different aspects of this. But yeah, I think we ended up with a very positive feeling about the OGC API features. We found it fairly easy to do what we aimed to do, which is to implement this on top of a triple store. I say one of the things that's made it so easy is that we haven't perhaps completely finished, that we don't pass all of the compliance checks from the OGC validation suite, but we will. Our aim is to follow up and tick those off. I mean, most of them are passing, but not all of the details. But so yeah, I guess to implement it to 100% compliance is a bit more difficult, but to get the basics done was fairly easy. Quite a lot of the time that we spent on this was experimenting with different implementations of geospatial and testing out their kind of completeness and their performance. And we settled on Fuseki as it had pretty good performance for the size of data sets we were looking at, and it was open source. One open question is how well this might perform in with very big data collections, and it may be that in that case that a different database that's more optimized for spatial queries may well perform better. We are aiming to run everything off a single database because that simplifies the data management in comparison to having to move data between systems and keep them in sync. So I think it would be a case there that for the majority of applications, you could probably run everything off a single database, but there may be cases for particular performance requirements. It would be worth using Postgres or one of the kind of more well-established ways of powering the OGC API, but at the cost of having to do some kind of ETL process. Once we've made this implementation on top of the triple store, if the data already exists, and in any case already we were always using the geosparkle vocabulary ontology as a way of representing geometry data inside the RDF. If you already have the data, then it's really easy to add a new collection. You basically have to write one Sparkle query and change a few configuration things in the API. So that was good. And we certainly feel that it's going to be useful to provide both of these options to support a broader group of users and use cases of this Environment Agency data. And in parallel to this work, we're in the progress of implementing an OGC API-based API for a new collection of data that the Environment Agency is interested in. So I think it's having a positive spin-off in that direction. And we, while there's, I think, more to do in terms of thinking about it, it's certainly possible and relatively easy to make links between different representations of something and between associated items. And the things that I think we feel that we haven't got to the bottom of yet, and perhaps run out of time, and also need to have some discussions with other people working in this space and get their thoughts, is one of the things about linked data is that it's a mechanism for providing a very kind of precise definition of what a property is. So every property can have a URI, and that means that you can hang other machine readable data off that identifier, and so you can provide, if you like, formal definitions of what your property means. In a simple JSON world, then properties are just strings. So that's nice and simple, and you can essentially solve the semantics problem by having separate documentation, your data dictionary, if you like, which is a simple and practical way to do these things. And that might be a good way to do it. The set of the links section of the OGC API is potentially a bit limited because of the limitation of the different kinds of links that you can have. But as we were saying before, you can certainly put links into the main set of attribute information about your item of interest. And we did start looking at the use of JSON LD, so if you like, the kind of linked data extension of JSON, which allows you to serialize linked data, RDF, in a JSON format by adding an extra element that essentially maps the sort of string type properties into URIs. And so that's an option for providing more precise semantics, if you like, of the links, but at the expense of turning the OGC API response essentially into RDF. So what we're trying to balance up is a more complex solution that can be interpreted in more than one way. Is that a good option, or should we keep these things separate and try and make them simple for the communities that like to use them, but be able to deliver both in an easy way and to make connections between them? So I think that's still an open question to some extent, but at the moment, I think we're reasonably satisfied with the approach that we've taken of having if you like, a separate OGC option and RDF option, but an easy way to provide both. So I'll stop there, because I'm running out of time. And if there's a couple of minutes for questions, then I'll be glad to take them.
Sorry for interrupting in the last second there, Bill. So
no, quite right. I was just seeing the clock.
Let's see. There's quite a long question from Peter Vertanos about the links in the headers. So they are meant mostly for navigation, and links that are meant to represent relationship between resources are probably best put into the links section. There would usually be too many association type links to practically put into headers. So that might be 100% clear might not be 100% clear in specification. So links in the section are not really limited to IANA links. The use of IANA is mostly if you can find a suitable relation from IANA, use that. Otherwise, create your own link relations and ideally register them with the OGC naming authority.
Yeah, no, thanks very much. Yes, was hoping to get some input from people that know more about the specification than me and what the intention of some of that is. So yeah, no, that's interesting. And certainly that link section is technically easy to extend with lots of other links. And yeah, I guess it's what is the process of defining those. So as you say, you could just make up anything, and we did do some experiments with doing that. I'll investigate further and talk to people who know about what that process of registering with the OGC might be. And I had a useful chat during the work with Rob Atkinson and some of the work he was doing around the OGC APIs and JSON LD and thinking about reusable sets of property definitions. So that's clearly an area that we could do more on that. And I think that some kind of ecosystem of link type definitions would be useful. Thank you.
Okay. So any further questions for Bill? Otherwise, I would first like to very much thank you, Bill, for your work. So thanks once again. And you also can't hear the applause, but your work is much appreciated. And then I have about 1 or 2 minutes left to wrap up this testbed. So I'm personally very happy with the results we achieved. And now it's on to for us to look into the conclusions. What does this mean for our national standards? So you can we'll be publishing probably or starting a public consultation of our geo extension in a few months, probably, where results from the testbed will be incorporated. And we've already heard about several invitations to present to diverse OGC working groups. So that's nice. If anyone else has an idea for a presentation, please contact me and I'll see what I can arrange to go into more details about the results of this testbed. I'll also, once the final little details in the report have been finished, publish a nice version of the report that's easy to share for everyone. And with that, I think I would like to wrap up for today. So just about on time. Thank you all very much for attending and hope to see you in some other circumstances. Hopefully one time again in person somewhere else. So thanks everyone.
Thank you. Bye.
Goodbye, everyone.